This presentation covers the implementation of the user interface on results from the tcpflow program. In this presentation, the environment is already set up with Elasticsearch, Kibana, and the UI. Instructions to run these components are covered in the report submitted along with this presentation. Elasticsearch runs on port 9200, Kibana runs on port 5601, and the UI runs on port 9000. In addition, the input tar.gz file is already uploaded through the upload page seen here. On the upload page, you simply need to specify the tar.gz file containing the folder generated by tcpflow. The folder within the tar.gz file should contain the following files: report PDF, report XML. Files with the HTTP body and file name are files carved from the HTTP messages. They're also called byte runs within the report.xml. Files without HTTP body and file name contains the raw content of the TCP connection, called file object within the report.xml. The folder corresponding to the report XML seen here is used internally by the UI to enrich the files read from the tar.gz. As mentioned previously, the terms file object and byte run comes from the report.xml directly. The report.xml also contains metadata related to the carved files, which will be useful in the UI. The report page is populated with metadata that's seen in the report XML and provides an interactive table through Data Tables JavaScript library that can sort and filter as needed by the user. The file object page, seen here, is populated with a section for tags, raw content of the file object. Note that it isn't populated here because I've carved out the HTTP message further down. Related file objects, which are based on the IP address and port for the source and destination being flipped. The carved HTTP message that mentioned earlier, in this case this is a request. And the entity, which is carved from the HTTP response. I'll be adding the add deal tag in this instance and navigating to a related file object, which already has this tag. It's being shown to demonstrate that there is a carved byte run object that represents the HTML page that is associated with this response. In addition, this is encrypted traffic just to demonstrate that the raw content is captured in the event that the program is unable to parse and break it down into the relevant traffic. The tags that were added from the prior action can be viewed here. Clicking a specific tag will provide the timeline of interactions along with table of the file objects similar to the report page seen earlier. Note that the tags can also be removed from the same form that was used to add it in the first place. This is the extent of the functionalities that is provided by the UI directly. Moving on to Kibana, which provides search and analytics capability. We have already set a timeline to arrange in the month of July, as seen here. There are over 9,000 entries that have been added as part of the upload process, which creates documents in Elasticsearch to be indexed. We're using Kibana to do our investigation because it has more flexibility provided through its query language. In addition, the integration of Elasticsearch with the UI needs work to support similar search capability. A search for eBay in this instance would return entries that have the keyword. The intention of this setup is to leverage Kibana to search and the UI to track and correlate interesting traffic. As seen in this expansion of the fields index, you can see the headers and the request line captured to better support search. Currently, Elasticsearch only has the headers for the HTTP message due to technical difficulties in trying to get the HTML content from the entity index. Note that it may be more efficient to use a proper data document store like MongoDB to persist the content, but Elasticsearch does provide for our use case during the initial development and useful search and analytics UI through Kibana. There are some improvements that could be made, but this is the end of the demonstration.